All right.
There we go.
Cool.
Topic today is developing for the web with extreme safety. So I'm a big advocate for safety, both organizational and psychological safety, but also technical safety. I think that safety is really what enables you to go faster. You can't go fast if you're not safe. And so that's one of the things that I really love about Elm. And I want to share some things that that I think are really incredible and innovative about Elm, but I hope that some of these principles will apply whether you're writing code in Elm or JavaScript or Java or whatever framework or language you may be writing in. I'm going to be talking about some principles that I've learned from the Elm community and the Elm language, and some of the innovations around that. This little circle on the right here is from something called Modern Agile. It's a movement that's kind of looking at kind of ways to work in a more modern way, not working with these traditional sort of styles where we're doing work in ways that are very unsafe and unpredictable, where we're moving in small empirical slices, and safety is core to that thinking. So I think Elm is really a great example of a framework that models those values in a language. So before we dive into some of the principles that I think make Elm and the Elm ecosystem outstanding for its safety, I want to hear from people in the audience. So I'm going to open it up to kind of pair discussions. Chat with your partner for a minute about what does safety look like in the context of the code bases you're working in now or that you've worked in the past? What are some of the qualities that have made it feel really safe when you're writing code, that have made you confident that once you've written something, you think it's going to work, you don't think it's going to break something off in a random part of the code base? I'll give you guys a couple minutes to discuss that with people next to you. Yes?
So would you give us a little 30-second bio on you and why you use Elm?
Sure. Well, yeah. So thank you for the question. So I'm an Agile coach, and what that means is I help organizations with really what I like to think of as full stack coaching. So that means that I'm helping at a technical level with kind of the team practices, things like test-driven development and legacy code refactoring, but I'm also helping with organizational things like team structures and having cultures where there's a sense of continuous improvement and that sort of thing. So whatever it takes to have to effectively deliver software in an empirical way where you're getting things out there where you can get feedback rapidly and safely. And so you want to be able, in order to experiment rapidly, you need to have safety backing it. You need to feel like you've got a safety net. And so those things are incredible safety net. So I actually, as a consultant, a year or two ago, I actually introduced Elm at a Fortune 10 company. That was coming in as an Agile coach, and I found that that really helped them with a lot of the things that I was working with them on, their technical safety practices. So it's been a big success story there. And they're actually, a lot of people from that organization are going on and giving talks about the success of Elm that they've had in the organization there.
And are you based in the Santa Barbara area?
I am.
Okay. And was the company that you were talking about based in Santa Barbara?
They were on the East Coast. Yeah, if you know me, then you probably know the company, but I don't know if they want PR around being Elm evangelists. So cool. Yeah, so I'll give you guys a minute or two to discuss what does safety look like in your organization or past code bases that you've worked on.
So what you would say, for instance, like using separate files that are we would worse, but then we realized that it also besides stuff that we can get.
Some TV. Well, yeah, because solely
Safety is so broad. In many different forms.
All right. I hate to break up a good discussion, but sounds like this is an ending topic. Why don't we kind of hear what some of the groups were talking about? Does anybody want to share some of the highlights of their conversation? What are some of the key points? Yeah.
So one of the things we're discussing is side effects. So like JavaScript right now kind of has this big problem. Like you're storing a lot of state in the program. It's constantly being mutated. You know, now we use global state stores and all this stuff to try to manage it, but it's still like in a lot in code bases I've seen it can get really out of control.
Mm-hmm. So having the side effects be kind of under control in some way,
yeah,
gives you more safety.
Yes.
Yeah, great. Are you you might have a little insider knowledge about Elm, maybe it sounds like.
I don't. I've never used Elm. I've programmed in like Rust and C++.
Wow. Okay, cool. Well, I didn't pay him to make that point, but cool. All right. So what are some other highlights from conversations? Yeah.
Good test coverage.
Good test coverage.
Written tests is, in my opinion, the most valuable thing.
Mm-hmm. Great. What other points do you guys have?
Effective types.
Effective types. You felt more safe with. You felt more safe having good types to have your back. Cool.
Like TypeScript instead of JavaScript.
Yes.
Like something like TypeScript.
Strongly typed language.
Strongly typed languages. Yeah. Cool. What other experiences have contributed to safety in your code bases?
Well organized and very readable code.
Readable code, organized, yeah.
Or seeing something go really, really wrong in front of you, and that prompts you to switch to a more secure, at least train of thought.
Right, okay, addressing problems that you've had in the past. Yeah, cool. Yeah,
Similar looking functions having similar like internal operations.
right, having sort of coherence.
Yeah, so if you use something that you don't necessarily, like, there are not going to be any surprises between two similar functions.
Right, reducing surprise, yeah, great, okay. Well, awesome, so everybody's experienced safety, and I think safety is a pretty universal thing. So, I'm gonna talk a little bit about Elm, and the things that makes Elm extremely safe, and in my opinion, the Elm philosophy is all about taking safety and turning it up to 11 and beyond. It's really radical in the way that it approaches safety. So some of you may have heard that Elm is known for no runtime exceptions. That's kind of the big headline. Do people read this? Yeah. Okay. Great. Okay. So just a little bit about Elm at a high level. It's a language for client-side web apps, so it would be an alternative to something like React or Angular. It compiles into JavaScript, and unlike TypeScript and PureScript and other languages like that, it lives in its own sandbox. And so that's a very key distinction, because it makes a deliberate choice to make it difficult to interact. Not difficult, but a very separate process when you interop with JavaScript. And that allows it to have a sort of purity within the sandbox that doesn't get touched by impurities of the outside world. So it calls JavaScript indirectly. The syntax looks similar to Haskell. It's got some OCaml influences. So it's an entirely different language, even though it transpiles into JavaScript. And the language choices often favor simplicity and explicitness over brevity. So these are some of the foundational things, and the headline of no runtime exceptions. So these are some of the kind of core things about the Elm language itself, where a lot of these innovations in the ecosystem are happening on the foundation of this language, and also I think inspired by the language itself. So I'm going to talk about some safety tips that I've learned and taken away from my experiences with the Elm language and the ecosystem around it. So the 3 safety tips I'm going to share are traceability, domain modeling, and consumer-driven APIs. Traceability. And we're going to talk about a couple of points here. Representing uncertainty as data and managed effects. So actually, the point about having some sort of constraints on side effects and some sort of predictability around where they're programming safer. That's one of the things we're going to talk about that makes the Elm language unique. And we're also going to talk about the way that Elm handles uncertainty and how that can make it easier to trace back to the origin of a failure. So uncertainty is data. How do you deal with uncertainty? So in Elm, there's no such thing as null. There's a maybe type. Now that may seem like a tomato distinction, right? Well, you can call it whatever you want, but you have some way of representing the absence of a value. So what's the difference with null? What's the difference between null and maybe? Can people in the back read this? Yeah? Okay, great. So the difference between null and maybe is that in Elm, if you have something that's an int value, it cannot be null. It cannot be nothing. It must be an int. So maybe is sort of like a wrapper around an int. So you could have an int, and it's never going to be nothing. You could have a maybe int, and it will sometimes be an actual int value, and it will sometimes be nothing. But you've represented that that quality. It's not sort of open field where anything can be null at any point. So that's the main distinction between maybe and null. So so for example, you've got uncertainty if you're getting the first element from a list.head from a list of 100, 200, 300, it's just 100. So just means that there's some value there. If you do list.head on an empty list, it gives you nothing. So so with Elm, if you have a if you're trying to get the first element from a list, and you tell it what to do, in case there's an item as the first item of the list, this is the value that I want to return. When you try to compile this in Elm, the Elm compiler is going to give you this feedback. You need to account for the following values, maybe nothing. So so the Elm compiler has our back. We can't leave implicitly for a failure or an exception to occur. We can't do, get the first element from the list and then do something from it and then boom, null exception. We have to explicitly handle, we have to explicitly unwrap it and check if it's null or not, and we have to tell it exactly what to do in the case that it's null. So this is what it looks like when you're actually handling it. So we've got this function described first that takes an argument of my list, and we're getting the list.head of my list, and we're saying in the case that there is an item in the first item of the list, this is our value. If there's nothing in the list, then do this. Are there any questions on maybe? Yeah.
I have a question on the language in general. How heavily is it based on Haskell?
It's actually more influenced by OCaml, and it's the length. And for anybody who can't hear the question, it was how heavily is the Elm language based on Haskell? There are actually some pretty significant differences, and many people say that Elm is more beginner-friendly than Haskell. Haskell is notoriously challenging to learn and to grok. Elm is actually a very friendly language to learn, even though there are a lot of similarities. And in my opinion, the way that it simplifies down the number of language constructs not only makes it easier for beginners, but it makes it easier for experts to maintain the code, because it's just as powerful with fewer language constructs. Yeah?
Did I read correctly that the compilers are in Haskell?
That's right, yes. The Elm compiler is written in Haskell. That's right. Okay, so uncertainty is data. So maybe is an example of uncertainty as data. You either have the absence of a value or a value. And that's just data, right? It's not a special type like null. It's just a data type. So traceability, another type of uncertainty are failures. So let's talk about failures. In Elm, there's no such thing as raising an exception. And so this is something as I've been working in different code bases and working in Elm, working in Java, working in JavaScript, working in Angular, working in these different languages and frameworks, I try to pay attention to where do we spend our time when we're working in these different languages and frameworks. And what are the points where you scratch your head and you say, like, how the hell did I get here? And spend like 30 minutes going down a rabbit hole trying to figure out how you ended up there. And one of those places I've noticed is exceptions. So in a way, exceptions are, everybody's dealt with global exception handlers and squelching errors and the frustration of trying to figure out the source of an issue when it's getting squelched. You've also got these propagating nulls that go deep into the system, and they get far away from the point of origin, and there's no direct way to trace them down. So, in a way, errors are traceable, as opposed to exceptions, because exceptions are very much like go-tos. Exceptions occur locally, and they're handled non-locally. So how do you know where an exception is going to be handled? You look at the code outside of it, not the code that calls it. You look at code anywhere in the stack trace. In Elm, an error is just a type of data. So how do you know where an exception is coming from? There are no global exception handlers. There are no ways to catch and raise exceptions and to try catch or anything like that. You just trace the data, because instead of an exception, you return data and you process that data. So here's how you handle errors in Elm. It's a type called the result type. So if we've got a function int or -1, it takes a user input stream and it calls string.toInt on that user input. And of course, the user input could just be ABC, and it's not going to be able to parse int successfully. But if we get something like 1, 2, 3, then the result is going to be okay, and we'll have the value. So we can grab that value, we pattern match it, and we just return the parsed value. Now this function isn't going to compile in Elm because we're not handling the error case. So we get this useful compiler error that tells us you didn't handle branch to cover this pattern. What if there's an error? So we need to explicitly tell it. We can't just not handle it and let it fail implicitly. So we just say if we get an error, we're going to pattern match and ignore the error message and return -1. So that's how you handle uncertainty as data with errors. Yes.
So every function will have an error case.
So everywhere where you're dealing with a result, you're going to have to tell it explicitly what to do if it's successful or if it's an error. But if it's only certain types of things can have errors. So parsing an integer can have an error. Calling any regular old function, calling 1 + 1 can't have an error. So you don't need to check for results for anything other than things that return a result.
Got it.
This is very focused on the type, right?
Yes, exactly right. Exactly right. So it's using types rather than a sort of exception type notation. And now one important distinction between exceptions and errors as data types. And you're exactly right. It's just a data type. With a data type, there's no escape hatch. Whereas with exceptions, for example, in the Java programming language, if you have an exception, if it's a type of runtime exception, then you don't need to explicitly handle the exception. So, that's one of the ways that the Elm programming language can guarantee, with a couple of exceptions, no pun intended, that it will not have runtime exceptions. One of those exceptions being infinite recursion. Elm hasn't solved the halting problem yet. But for very large code bases, there are there's an Elm code base now that I think is approaching 1 million lines of code. It's been in production for 3 years or so, no red ink, and they've yet to have a single runtime exception due to Elm in their code base. And they have quite a few users. So now you don't have to explicitly do a case statement over every single error in Elm to figure out, did this succeed or fail? There are other ways to deal with it. For example, there's a function result.withDefault. if you do result dot with default, it will take your value and unwrap it and replace it if it's an error with the value that you provide. So that's a pretty handy function. So there are a lot of sort of nice functional ways to deal with this in a very elegant way. So it might seem very heavy-handed, but when you're using a lot of these sort of functional programming techniques, it ends up being quite elegant and readable code. Not to mention testable. Okay, so managed effects. So side effects came up as something that can make a code base feel more safe or unsafe depending on how they're dealt with and handled. So in Elm programming language, side effects are dealt with in a way that's referred to as managed side effects or managed effects. So what that means is that side effects all funnel into a single point. So if you've used Redux with React, then you'll be familiar with this pattern because Redux is actually a direct port of the Elm architecture pattern over to React. So what's his name? Dan Abramov was reading about the Elm architecture and said, "Oh, that looks pretty cool. I want to port that over to Elm," and that's what he did. So there's a single point where all impurities or non-determinism or side effects stem from, which is really, it's hard to overstate how nice it is to work in a code base where you have this guarantee that there's one point of origin for all non-deterministic things. So, you know, if you've ever worked in a code base where on the first of the month, the tests start failing on your CI machine. Why does that happen? Well, because there are these non-deterministic things. Checking time. Checking time is an impure thing. If I check the time now or in 10 seconds, it will be different. So it's impure. And because a test suite depends on that impurity, it's non-deterministic. You can run the test once and then run it again, and it'll have two different results. That seems pretty inconvenient. So what Elm does is it actually pushes out all of that impurity, all of that non-determinism into one central spot. And every single function that you write injects those impurities, but the code you write itself is pure. So it's impossible to write a function in Elm that running multiple times will yield different side effects. Any function that you write in Elm, given the same inputs, will have the exact same outputs. If you want to get the time, you can get that as data. But your code itself has to receive it as an input. So it's more traceable. So it comes from one point of origin. So that's this idea of managed side effects. So all of the results of that non-determinism funnel into this one central place. So this is what the Elm architecture looks like. So you've got this sort of impure world of side effects and mutations, and you've got this pure world of pure functions. So the code that you write in Elm lives in this pink space here. This is the browser, the Elm runtime. This gray box here is the Elm runtime. So the thing that's actually performing the side effects, for example, checking the time, making an HTTP request. Those things, you don't do them in your code directly. You do them in, the Elm architecture performs them for you. So why is that an important distinction? Well, because what you do is you tell the Elm architecture through this one central place called the update function. Tell the Elm architecture, hey, I'd like to know the time. And then you receive a message back from it as data that contains the time. So instead of performing the side effect directly, there's a layer of indirection. So you're not directly depending on it. You receive it as an input. So this is the gist of the Elm architecture. The Elm architecture tells you what the current state of your entire application is, and it tells you an event that's occurred called a message, like a user clicked a button, an HTTP request completed. I just checked the time for you, here it is. Those are examples of events or messages in Elm terminology. So those things come through to the update function, then you tell it what to do based on that. And you tell it your new model, the entire state of your application. So you say, oh, a user clicked on this button, change this piece of my state of my application. You give it the new state, and the Elm architecture holds on to the state of your application and manages that for you. So you actually never mutate the state of your application directly. You describe the changes to the Elm architecture, and it changes it for you. Because data in Elm is all immutable. It's a pure functional language. So anyway, that's kind of it in a nutshell. And the view function is purely deterministic. So if you pass a certain application state to the view function, it will render the exact same view no matter what time of day you call it, no matter what API service is available. It's independent of all of those things. It's only dependent on your data, your application state. You pass that in, and it tells you what your view should look like. And it renders it using a virtual DOM similar to React. Like this could be a whole session, but are there any quick questions I can clarify anything on the Elm architecture? Yes.
So I'm pretty familiar with React Redux. I'm looking at this and trying to figure, it looks somewhat similar, but I'm having trouble like getting what the difference.
Yes. Okay. Thanks for the question. He was asking how do you map between the domain of Redux and Elm and the Elm architecture. So the update function is like a reducer. I believe messages are called events. That's been right?
Actions.
Actions, thank you. Okay. A message is an action. The update function is a reducer. And I mean the model is the state. Is that right? That's the gist of it. Does that help? Okay. Okay. So the second safety tip that I've gotten out of Elm and the community around it, domain modeling. So this one may seem like, how does domain modeling help with safety? Well, some things came up around having easy to understand code and having cohesive code that's easy to recognize what something's going to do. Those things are all valuable and good things in data modeling. But one thing I've experienced with Elm is that learning Elm has changed the way I think about code, and it's changed my relationship to type systems. In Elm, often people will use types. They'll often do kind of type-driven development where they'll be writing types first. Now, I'm a huge advocate of agile technical practices, test-driven development, and things like that. But I find even when I'm doing very strict test-driven development in Elm, which I do, it's wonderful for that because it's a pure language, and pure languages are great for test-driven development. But even when I'm doing very disciplined test-driven development in Elm, I find that I'm writing first around with the domain model. Now, I'm not writing logic for those types, but I'm playing around with the types. And the reason is because types allow you to make guarantees that are a little bit more difficult to write into your code. Because a type is a more concise expression of certain constraints. So there's an incredible video that I highly recommend for anybody interested in learning more about Elm. If you only were to watch one 20-minute video about Elm, I would say check out Making Impossible States Impossible by Richard Feldman. And what it kind of talks about is modeling these constraints in a way that you not only can you feel confident not writing a test for them because the compiler is handling it for you? It would actually be impossible to express a test for it because it wouldn't compile. So you get really used to that as you're modeling things in Elm. And actually, a lot of people who are new to Elm are not leveraging the type system and getting the safety out of that. So that's it's a big mindset shift. But once you make it, you can actually apply it to a lot of other languages. Like TypeScript has some of these capabilities, albeit with more escape hatches. Contract-driven design. So I'm going to get into these points a bit more, but more compiler guarantees means you have more focused tests and fewer bugs. So test coverage is one of the best things you can do for improving the safety of your code base and your confidence and ease of navigating it. But what happens often is people have noisy tests, useless tests, trivial tests. And this is something I see again and again. And with Elm and the safety that the language, the type system, the domain modeling of the type system provide, you need fewer tests. So the tests you do have, there's a very good signal-to-noise ratio, which is, in my opinion, key to safety. If you have noisy tests, those tests become less safe, and you're less confident from that. Okay, so let's talk about a few of these points. Contracts. So what do I mean by contracts in the way that you model your domain? So without contracts, errors creep deep into the system and they're harder to trace. So in Elm, there's this concept that's really that comes up again and again, both in the language itself and the ecosystem around it, of enforcing contracts at the gate. So in Elm, there's this tool called a decoder. And a decoder, what it does is it takes something from untyped data into typed data. For example, if you've got some JSON that you just got back from the server, what's the type of the JSON? It could be a string, it could be an object with some keys that are ints and strings. Some things could be null. Maybe some of the keys can be null, and maybe some of the keys can never be null. And in Elm, we use the maybe type to represent those types of distinctions. So in Elm, you can't just take this untyped data, JSON, and just reach into it and grab things, and then let it fail if your assumptions are incorrect. You actually check your assumptions at the gate. So before it enters Elm land, it must have types. And the way that you do that is with something called a decoder. So essentially what a decoder does is you express all of your assumptions about the data that you're parsing, and it will give you a failure if any of those assumptions are incorrect. And otherwise, you know you've got data of the type that you expressed your assumptions about, and you're free to use it however you want. So it's kind of like a extreme vetting at the gate, so to speak. So that may be an unpopular topic right now, though, but it works out quite nicely in code. Okay, so let's get into decoders a little bit. So, and at first, these decoders are an annoyance. It might seem like a big pain, and it is at first. But when you learn them, you'll feel like you can't live without them. So let's say this is just JSON. This isn't Elm. Let's say that we've got this JSON, and then so we could call this function decode. We're just going to do decode string here, and we're saying I've got a field with first name. So here's our first key, and it's got a string, Beverly. So we parse that out. So this is our decoder. In the parentheses here, this is a decoder. So that's expressing our assumptions. So what it's saying, what we're saying our assumptions are, is that we have a field, we have a key called first name, and then the value of that key is a string. And indeed, that's true here. We do have a key called first, and we do have a value that's a string with the value of that key. Oh, whoops, sorry, that's about there in my slide. So the value that we'll get is OK Beverly. So when we parse it like that, since our assumption was correct, we get a result type because it could fail, it could succeed. It succeeded, so we got OK instead of an error. If it had failed, we would have gotten an error. And it would give us a message saying, I expected an object with a field named first, but instead got. Sorry for the typos in that slide. Okay, so let's talk a little bit more about domain modeling and this concept I talked about of having making certain states impossible to express, so that even if you wanted to test them, you couldn't. That's how much of a guarantee it is. So how does this data type look to your eyes? We've got in my experience, this is a quite common and quite normal data structure. We've got a JSON object has error is true. Error message is some error message from a server. It's a string. Done loading is true. And the data that we got back from the server is null. So this is pretty reasonable, right? That's a pretty good way to represent the data that we got back from the server. We need to have some way to contain the data if there is data from the server, or if there was an error, we need to know, and we need to have an error message for it, right? So it seems quite reasonable. When you work in Elm for a little bit, your eyes will look at this and see a lot of opportunities for getting the compiler to support eliminating these nonsensical permutations of this data structure. So let me show you what I mean. So here, remember these data types. Has error, error message, done loading data, right? Those are the data types that we're modeling here. Okay, so we've got data, we've got done loading, we've got has error, we've got error message, right? So let's say that we've got, so this is just a straight up truth table, so to speak, that I made for this data structure. Is data null or non-null? Like, is there data or is there not data? Is it done loading? Is done loading true or is done loading false? Is there an error or is there not an error? Is there an error message or is there not an error message? Okay, so the first one, there's data and it's done loading. That's reasonable. And it has an error and an error message. Well, I don't want that state. So what do? We write a test for that, make sure it never happens, and hope that we tested all the ways that could happen, and get confidence from that, right? There's data, it's done loading, there's no error message. That's valid. So actually, when it comes down to it, there are only 5 states here that make sense, that we actually want to be able to represent. So Elm gives us a way to represent this data without all the red, without most of the ways that that this data type could be filled with data being invalid or undesirable states. And so this is called a union type. In fact, maybe and result are examples of the union type. So maybe can either be nothing or something. It's called just in Elm lingo. Like just an int or nothing. So so we can model this this type of state where we're getting some data from a server and it could have an error, it could have succeeded, could be loading, could not be loading. So the way that you model it at home is just, we've got this remote data type. It's parameterized with something called data. So maybe we expect to get an int back from the server, maybe we expect to get string. And we could have not asked. We could be loading the data. We could have gotten some sort of failure, or we could have gotten success. Now, if it's success, it will have this data, whatever the type of our data is. If it's failure, it will actually, in this case, have an HTTP error. Now, HTTP error is a union type, which is going to be could not connect, timeout, things like that. So it's actually a discrete number of possibilities rather than an infinite number, more or less, which a string could represent. So for example, here are some ways you could construct that. Under constructing union types, we could have success, and that's got a record under there, which is similar to a JSON object in Elm, which has a first name and a last name. We could have a failure with an HTTP timeout, or we could be loaded. So those are all different examples of ways to construct something of that data type. And it turns out this is a package in Elm, Chris Jenkins / remote data. It's a really great and very simple package, and you'll find that it cleans your code up tremendously because you have this nice, concise type to represent all these different states. And it actually ensures that if we look at a data type like this one, we can go and grab data without checking if it's done loading. We can go and try to grab an error out of it when in fact there was no error and it successfully loaded the data. We can forget to handle certain cases by making assumptions. So actually, you'll see very often that when it's loading, it'll say, you have 0 messages, and you're like, what? I definitely have messages. And then it finishes loading, and then it shows your messages. With a union type, you're forced to handle every single case, and so you find fewer of those bugs occurring. It's quite cool. I definitely recommend playing around with this if you're interested. Okay, and then the third safety tip I'm going to talk about today is consumer-driven APIs. So this one's a little bit more subtle than the other points, in a way, but I think it's just as profound. What does UX for APIs have to do with safety, right? So to me, it has a lot to do with safety, actually, because if you have a simple consumer-driven API, you're going to be guided towards correct use. So it's less error-prone. You're going to have a more minimal interface. The more minimal your interface is, the less that could go wrong, and the less likely it is to be misused. Trying to support everything is not only an inconvenience, it's actually a safety hazard. And so it's not just a nice design consideration, it's, in my opinion, central to reducing bugs and increasing the delivery speed of your team. So start opinionated and minimal, and this is a common characteristic that I see in both the Elm language and the libraries written for Elm. And in fact, I've been extremely inspired by a lot of the innovations in the Elm ecosystem and the philosophy of simplicity and doing the right thing. For example, there's a library for building graphical visualizations. And the woman who built this library was reading all about visualizing data in the process of building this library, and she discovered that humans are intrinsically poor at judging volumes within a pie chart. And so instead of putting in pie charts to her API like every other visualization API, she decided to eliminate that. So she had this opinionated idea that this is the effective way to communicate visual data to humans, and I'm going to take a stance and not provide a way to do bad data visualization in my library. I'm going to keep it simple and opinionated. And then you introduce flexibility as needed. And driven, that's why I call them consumer-driven APIs, because it's driven by actual needs. Start with a simple set of assumptions. If those assumptions are proven to be wrong by actual people using it, then go ahead and respond to those changes. Okay, so I'm going to talk about, I'm actually going to give a quick demo of this package, which I think is a shining example of this in the Elm ecosystem, called style elements. So style elements, some of the really cool things about style elements is that so style elements, Richard Feldman actually described it very nicely as, he said, it's looking at CSS as bytecode. So it's a sort of higher level abstraction around CSS, and it actually eliminates the cascading element of CSS, which is actually a very difficult to maintain thing. It's hard to trace where is this style coming from if it could be cascading from a number of different places and be overridden a number of different places. In the style elements package, you actually specify all of your styles in line. You don't specify them with a templating language, you specify it in the Elm language. So you can abstract it however you'd like. You can extract it into a constant, you can extract it into a module, you can extract it into a function and parameterize that function, that's all fine. But you can trace back exactly where it's coming from and exactly what it's going to be deterministically without having to go through all these cascading rules in your head. You can see, oh, it's calling this function to get this style, and go and trace where that's coming from. So there's no cascading, no levels of indirection there. It's all directly traceable. There's no separate DSL for style sheets and classes. So you've got this, again, simplification and minimalism, which it's not only a nice user experience, it's safer to reduce the number of constructs here. We already have a perfectly good Turing complete language. Why create a whole nother language within that? And it can actually, having this high-level API, it can help enforce certain elements of accessibility too, which is kind of neat. Okay, so let me give a quick demo of this here. Okay. So we've got this super ugly nav bar here. So there are a number of issues. As you can see, it appears to be centered vertically, which is super weird, and it's, well, let me duplicate my screens here. The padding is all messed up, so we've got some work to do. So let's look at our. So this is written in style elements, and what I've done basically is I made a bare bones nav bar with no sort of styling. So now we can go and apply some styles and see what that looks like. So let's try it. So as a first step. How about we try getting these things sort of split apart evenly? Because I want to have my logo and then my links and then the avatar be kind of spread apart. So how would you do that in CSS? Flexbox and yeah, do a bunch of magic around that. With now before Flexbox, of course, it would be a lot trickier. Here. Here's the really cool thing about style elements is if you're looking to change the style of something, it's all in line. So there's only one place where the style can come from because it doesn't cascade. It doesn't cascade at all, right? So if it doesn't cascade, if we're trying to change the way that these things are laid out, the only place that could come from is this top level element here, this gray box. So let's look at the code for that gray box. Okay, so I happen to know that there's a space evenly. There we go. That spaces it out evenly. Now, again, this is very simple code that I've got here. But the really cool thing is no matter how complex and large this code base becomes, it's going to be just as easy to trace and find exactly where a style is coming from. No matter how big and complex this code base is, I know to look in this element to hone in on the place where I need to change that style. Okay, so these things are kind of hugged up against each other here about contact testimonials. So where do I look for that? Well, it's pretty clear that I've got, this is like one element here somehow. So what's the parent of these elements? Because again, it can only be local. There's no cascading. So let's look at the parent of those links. And it turns out there's a little guy called links here, so let's look at him. Now this is nothing more than a constant. So I'm going to go into links here, and I'm going to say, I'm going to add some spacing, maybe like 10 pixels, maybe make it 15. That's pretty good. So that's the basic idea, and of course, we wouldn't want to leave it without changing the main element here to be line to the top. So that's the gist of style elements. How much time do I have? Okay, I've got a little bit more time. So, are there any questions about style elements before I move on? Yeah.
Has this influenced any other languages so far?
The style elements package in particular? Yeah. That's a good question. I'm not sure if it has. I know there are some in React and other ecosystems. There are some packages for more localized scope CSS. I don't think it's necessarily been influenced by style elements. Style elements is unique because it's not trying to just be CSS. It's trying to say, if I were describing a layout to a designer who knows nothing about CSS, would I say, okay, this should have this much margin, and this should have that much padding, and this should be, you know, vertical align. You know, you wouldn't necessarily use those terms, right? You certainly wouldn't use a term for margin and padding and expect your designer to understand it, right? So style element says, well, okay, well, let's talk about it the way that a human would understand it. Forget margin. There's no such thing as margin. There's only padding. And so it makes a lot of simplifications like that, and it tries to be more sort of human-centric. Okay, so one last thing to talk about here. So this is a package that I built that I'm going to talk about. So so something that you find often when you're dealing with command line interfaces is these sort of confusing error messages when you're using a command line interface incorrectly. You pass in an unknown parameter, and it often just ignores that parameter, or it doesn't know how to point you in the right direction. So actually, this is something I was pair programming with somebody the other week, and we were trying to initialize an Elm project with a test suite. So we were running Elm tests -- init, which seemed like a pretty reasonable way to initialize a test suite. And then we got this message: no tests found in the test or tests directory. Note, make sure you're running Elm test from your project's root directory, where it's Elm package.json lives. So we're looking around for the Elm package.json, and we're like, no, we're running this from the right directory, and we do have an Elm package.json, and it's formatted properly. So we're running around in circles looking at that. And of course, we didn't look a little bit further down where it says, to generate some initial tests to get things going, run Elm test init without the --. So it does in fact tell you that there's this Elm test init command that you can run. Why does it do that? Because you've probably got people running into this type of problem all the time. So they hedge their bets and they give you a bunch of helpful information that tends to be what the problems that people run into when they run their tool, right? But of course, if you run elm test -- foo, it's going to give you the exact same message, right? It would be helpful to know that it has no idea what you're talking about when you say foo. So why does it do that? Well, I've grabbed all the code from the Elm test command line interface here. So this is JavaScript code. Since all the node stuff you can't quite do in JavaScript now, it kind of does front end stuff only at the moment. And if you look for args dot, compiler is one of the flags, so it's checking for args.compiler. If args.compiler is not defined, then tell you this then. If args.help, then do this. If args.version, then do this. Pass args.verbose through to here. Now, with this kind of code, you could imagine that there are all sorts of opportunities for it to be kind of silently ignoring some of the things that you carefully handcrafted and passed into it. You want to tell it, run things with this output format. You spell it incorrectly, and it doesn't give you any feedback that you should expect your flag to not do anything because it doesn't know how to handle it. Right, so this is very common because it's this sort of imperative way of lazily handling a contract. It's lazily enforcing the contract as needed. So again, there's this Elm philosophy of enforcing a contract at the gates. So I've got a package called Elm CLI Builder, and what it does is it does exactly that. It handles this contract at the gate. So I've kind of recreated the contract of the Elm test command line interface here. So if I do my same mistake here, Elm test -- init, it's actually intelligent enough because it has the entire contract up front. It has the entire contract expressed, instead of being scattered all throughout this imperative code in how to handle and process the command line arguments. It's in one declarative place that says the exact contract, and it can enforce it up front at the gate. And it can say, hey, someone just gave me an init flag. I don't know what that is. Oh, but I do have this init subcommand. And it's spelled similarly, so it can suggest a typo. Of course, it would be a similar thing if I said -- foo. It doesn't know about -- foo. Oh, it actually gives us a different suggestion because -- fuzz is more similar to foo than init. So I'll show what that looks like here. So this is how you specify. Now you don't have to grok every single word here, but the important point that I want to convey is this idea that there's one single place. If you recall the code for the Elm test command line processing, it's this giant file where it has this interspersion of check for flags, process stuff, then check for this flag, then process this, then keep going, do this validation on this input from the command line interface. So it's all interspersed. So how do you look at that code and say, if I pass these command line arguments, would it be valid? What would it do? You'd have to go through the entire file to understand that. Whereas with my package, again, using this sort of Elm philosophy of enforcing the contract at the gate, it can say, you can look at one central place and say, will this be a valid command? Yes, it will. Will this be a valid command? No, it won't. And in fact, if it's not a valid command, it will tell you. And you know, for the help text, you don't need to have this manually generated help text that could get out of date. it will automatically generate help text for you based on the contract that you've expressed. So it's guaranteed to be in sync. So that contributes again to safety. Okay, so I think that's all I've got time for. So let me skip to the closing here. So again, these some of the takeaways that I've had for designing my own, both internal and external APIs, open source APIs and APIs within code bases at workplaces. These are some of my takeaways. Start with the constraints that you want to enforce and work backwards. Guarantees are better than discipline. I'd rather know that the compiler is going to not compile if I didn't handle a certain case than have to remember to always handle this a certain way, or to know that I have to test all the corner cases around this. And fewer features is not just convenient and faster, but it's safer, and it means fewer bugs. So, so these are the core concepts that I talked about: traceability, domain modeling, and consumer-driven APIs. Traceability, we talked about uncertainty as data and managed effects. Domain modeling, we talked about making impossible states impossible, and contract-driven design. In consumer-driven APIs, we talked about guiding towards correct use and minimal interfaces, and being opinionated and minimal. That's all I've got for you today. Thanks. Yes?
So in my Google's getting a large L for a while now.
Yes.
I've been following it from afar, and I've also been reading lots of comparisons with ReasonML. Do you have any experience with ReasonML, and which one would be worth learning over the others? A lot of discussion on ReasonML fitting into that niche, particularly with enterprises, and going mainstream where Elm didn't.
Right. Right. So ReasonML versus Elm, and why would you learn one over the other? Yeah, that's a great question. So ReasonML, I haven't really played around with it a lot, but it does seem very cool. One of the things that really differentiates Elm from some of its competitors, really, I don't think of them as competitors, alternatives that have a different philosophy and a different set of design trade-offs, is that ReasonML and PureScript and TypeScript is a little more on the spectrum of being close to JavaScript and easy to use with JavaScript, right? Elm is very far on the spectrum of, as far as trying to be close to JavaScript and to interop seamlessly with JavaScript. It actually says, no, we don't want that. We actually consider it a feature to not be similar to JavaScript and to not be tied to JavaScript and to not have to seamlessly interop with it. So with ReasonML, there are more escape hatches, and there are more ways to, there's more of a sense of directly interoperating with JavaScript code, which is very nice if you're working in a JavaScript code base and you're trying to piece by piece change it over to a different language that transpiles to JavaScript. That's great. With Elm, that's not really the philosophy. So something like TypeScript would be a much more extreme example of very gradually being able to introduce this language and change over. With TypeScript, you could actually just introduce a little configuration file and a transpile step and start transpiling and change your .js to .ts, and now you have a TypeScript code base because it's a superset. That's super cool, but you don't get the extreme safety, and you still have a lot of the escape hatches because JavaScript has them. And so to me, the killer feature of Elm is that it doesn't have those escape hatches. And so within the sandbox of Elm, it can guarantee this radical safety. It can guarantee no runtime exceptions. It can guarantee that the code that you're doing is pure. It's not optional. It's not like, should I use this library to be doing immutable data structure changes or not, it's not optional. That's just how you do things in Elm. Should I perform this side effect here, or should I perform this side effect in one of my in this particular function? In Elm, you don't need discipline for that. It's just baked into the language that you can only do it this way. So it's a more radical approach, which means it's not going to get as much adoption, but the people who use it do love it. And the safety trade-off, in my opinion, is really worth looking at. And also, as I hope some people are inspired to do today, to learn from that philosophy. Yeah.
Two questions for you. The first one being if there's any popular web apps that we would be familiar with that use Elm, and the second one would be if I only have one day to mess around with Elm, do you have a recommended tutorial or place that I should spend my time for a quick brief on Elm?
Great questions. I know that some Procore people are, I don't know how to look on this resolution, but are familiar with Mobster, this mob programming timer. So this is a very popular application. This is an app that I built for mob and pair programming. It kind of is a timer that will run in the background and make sure that you're swapping at the keyboard so everybody's kind of getting a turn. So this is actually an Elm Electron application. There are some major companies using Elm. I don't know of any everyday applications that we use that I can say use Elm off the top of my head. There may be some, but I'm not aware of them. And as for learning resources, it's a good place to start. So in terms of getting inspired about Elm, that video by Richard Feldman, Making Possible States Impossible, is excellent. It's a great intro to the Elm philosophy. I've heard good things about the Pragmatic Programmer's intro video to Elm. I've heard really good things about Richard Feldman's Front-End Masters course on Elm.
Thanks.
Yeah, absolutely. Yes?
Anything about Elm you absolutely hate?
Anything about Elm I absolutely hate?
Maybe
have
not
to
absolutely.
think about that a little bit. I hate that I can't do it on the server. I hate that I can't do it easily on the server. And really, the things that are really important to me, Elm nails. As far as minor annoyances, there are a few, but really minor ones. I can't think of any major things that on a regular basis annoy me when I'm using Elm. A lot of people, when they're using Elm at first, they'll express frustration that like it should be easier to express it this way, or this should be more concise. And a lot of the arguments that people in the, that a lot of the kind of thought leaders in the Elm community make is that, is this thing not being more concise really what's slowing down your productivity and making your code base worse? Because often, again, Elm makes these trade-offs of being explicit rather than concise. And so, I mean, and you've also got these decoders that I talked about, right? That's often an annoyance that you have to explicitly write out kind of your contract for the data that you're parsing. You get this data from the server, and you have to explicitly say, I expect it to look like this. And that's very laborious. So that can be an annoyance, but it's much safer than the alternative of letting all of these kind of undesirable values slip deeper and deeper into your code base and farther away from the point of origin where they were introduced. And then you find this like, how the hell did this value get here? But there are some pretty cool things. I'm actually exploring some cool things around that. Like I've built this library that takes a Graphql specification, a Graphql schema, and it generates type-safe code for Elm to hit that schema. So you don't need to write any decoders at all, and it will safely parse the data correctly. So I don't know. I mean, I may sound like I'm kind of being lame and pretending that everything about Elm is awesome, but genuinely, the things that are really important to me, Elm kind of nails. There are some things that could be improved, and maybe some like meta-programming things could be nice, but it's also kind of nice that it's so explicit and doesn't have some of those things. It's not hand up there yet.
You mentioned several times that, like, I think you was asking your question about not being able to use it server.
Yes.
Could you talk more about that, like what's going on with that?
Yeah, absolutely. So like for example, this this command line tool that I was demoing that I built, this command line kind of API for building command line tools. That's Elm code, right? So you can do non-front end stuff with it. You like Node. It's just that it exposes a lot of features of the web platform in a way that's really nice to use. So for example, I mentioned how these side effects kind of are being performed by the Elm runtime, right? Like making an HTTP request, connecting to a WebSocket. It's actually very nice because you can be very declarative about it. So you can kind of say, rather than being imperative and saying, okay, try to open up a connection to the WebSocket at this address, then do this handshake, or do this if it fails, and then do this backup or whatever. You actually just say, I want to be connected to this WebSocket, and I want to listen for data, and I want to get this message when the data comes in. And the Elm architecture will perform those low-level details of the exponential backup and all those types of things for you. So it abstracts it away, and it's very declarative, which is awesome. The problem is, it kind of needs to have fleshed out those APIs of the web platform, which it has done. But if you're going to do something like Node, like a server, and you want to be able to get data from a database and perform other side effects like that, you need a nice way to do that without just reaching over to Node APIs all the time. And so basically, can you do it? Is it possible? Yes. Are people doing it? There are people doing it, yes, but it's not idiomatic and it's not elegant. And that's the thing that people love about Elm, is that it's such a streamlined experience. And Elm is both a language and a sort of platform or framework. And so there's this sort of quality that things feel really seamless when you're working in it, and they're very approachable and easy, and they feel safe. You're not going to have that experience if you're trying to build backends. Now, Elm doesn't have concrete plans to build a server-side version of it. Basically, what Evan Shiplicki, the creator of Elm, has said is that once Elm is at a point where you could say, like, where no one could say, well, Elm is good, but if it had this one feature, if it had tree shaking, if it had whatever, then I'd switch to it. Once it doesn't have any more things like that, any caveats that somebody could say, well, it's almost ready for me to use. It's almost perfect. Once it's at that point, then he'd like to start looking at it. So there are no plans in the near future for that. Yeah.
Is there any sort of like proof of correctness or something for the runtime itself, or how do they kind of ensure that like, the unsafe, unpure things that the runtime does is actually correct?
Right. So that's a great question. So there aren't any sort of proof of correctness things other than, tests and sort of the release process of kind of validating it through that release process. But the way that they kind of approach that is by making it as minimal as possible. So so there's this sort of, and this has been a controversial point in Elm, but actually what you find a lot is that when people are complaining about, so Elm has this very strict philosophy that basically side effects are the difficult part about programming. So the philosophy is, since that's the difficult part about programming, let's be really, really careful about it. And that means you can't just do them willy-nilly. You can't do them anywhere you want. You only do it as managed effects in this central point update function. And you can't have just anybody writing packages that do side effects, like HTTP requests and WebSockets and things like that. So so what Elm's philosophy is to be very minimal about doing those things, so that most of the code can have this sort of proof of correctness because it's not performing side effects. So they're basically their way of dealing with that is being very conservative about how they allow side effects to be performed. So you can't just publish a package that performs side effects. It needs to be kind of a blessed package to do that. And there's a formal process for that. Now, this has been controversial for some people, and what a lot of people in the Elm community say when these people are complaining about this philosophy is, they'll say, well, it sounds like you would really like Reason ML. Sounds like you might really enjoy TypeScript or PureScript, because they have a different philosophy about that. They are much less strict about the way they deal with side effects. Yeah.
So learning curve aside,
yes.
Once you're fully ramped up, despite all the things you mentioned about like having to write decoders and things like that, would you find that your development is quicker at the end of the day?
Yes.
And even though you kind of knocked like the TDD thing a little bit, you'd still, of course, be writing tests for. Oh,
absolutely, absolutely. Well, yeah, and I didn't mean to knock TDD. I'm a huge advocate of TDD, but what I found problems with is when you have test suites that are full of noise, where you look at it and you're like, oh, this is a trivial test, this is a trivial test, this is a trivial test. Well, why is it a trivial test? Because you don't have confidence that it's going to work unless you test it. Elm gives you confidence in those trivial things through the type system and things like that. So you don't have to check, is this thing getting passed in correctly? Is this nonsensical state somehow being arrived at? Elm can help you guarantee those things won't ever happen. And so your test can focus on the signal, not the noise. But so yeah, do I find that I'm more productive once I get past the learning curve? Absolutely. And the reason is because again, it's because of these kind of core ideas of safety. So from my experience, safety is what results in speed in a code base and on a team and in an organization. So Elm provides all these types of safety. If you have the compiler has your back, somebody can come into a team on day one, even if they've never written Elm. They don't need to read up the manual on best practices for this framework, right? In order to be like, hey, don't use this language feature because it's not good. Always use the triple equals or things like that, right? It's just the language is safe by default, so you can just jump in and make a change and feel safe on day one. I think there was a. Did you have a question? Or?
I think I'm going to ask.
Yeah.
Are they looking at WebAssembly as a compilation target?
And actually, one cool thing about WebAssembly and Elm is that the way that Elm works with the Elm architecture, you could actually implement, since WebAssembly is so low level that it doesn't have like automatic garbage collection or anything like that, right? You can implement your own memory management. You could actually implement Elm in WebAssembly without a garbage collector by basically anything that's, this is the only place where state changes occur. So every time the Elm architecture calls the update function, you allocate the memory that you need for it. And then once you perform the computation, you've got the new state, you pass it over there, you deallocate all the memory that you allocated in here, and then repeat the process. So you don't need a garbage collector, which is super interesting.
Where did the name come from?
The name came from looking at spaces of names that could be interesting and pleasant and short. That's basically how it was. Elm trees were a nice name and sounded cool. Yeah.
So, you know, like it seems like there are a lot of really good things about Elm that I learned about today. Why do you think that not as many people use that as opposed to other JavaScript frameworks or other? Obviously, it's its own language, so there's a learning curve. But it seems like the fact that it's very restricted is also kind of skeptical.
That's frustrating to a lot of people at first. I think so. The Elm community is actually growing pretty rapidly, and there's kind of a philosophy in Elm that you don't necessarily need viral adoption for a language to be successful. If you have people using it robustly and loving it and a growing community and a great set of packages. So this was actually at this Fortune 10 company where I introduced Elm. This was kind of one of the concerns was, you know, we're hopping on this language. This was a very slow-moving company, you know, as a large enterprise would be, to adopt new technologies. So it was scary, and there was Angular all over at this organization. So there was concern about introducing that. One of the arguments we made was that there are all these teams that are using Angular, and when people jump from one team to another, they actually find it quite difficult to get accustomed to a new code base and feel confident changing code in it. But if you have all of these safety features of the Elm language, that's not the case at all. Even if there's that learning curve of Elm, you know that if you totally mess something up, the compiler's going to tell you. So you can experiment freely. You can learn rapidly because of the safety. So, I think that the Elm ecosystem, the Elm community is growing actually pretty quickly. Is it going to overtake JavaScript or whatever? I don't know if that's necessarily the goal. Yeah, but I would definitely recommend checking it out if you're interested. All right. Well, I'll hang around for a bit after if anybody has more questions, and feel free to reach out to me anytime if you want to chat about Elm. Thanks.
Great talk. We always appreciate our speakers. Getting up here takes a lot of guts and effort to put a talk together like that. Let's give Dillon another hand. It's not the first talk we've had about Elm, but certainly one of the deeper, more substantive ones. I think it's a fascinating comparison side by side, having JavaScript, one of the least safe, quirkiest languages out there, side by side with Elm, which preaches extreme safety. A lot of great points. Really enjoyed it. Next month, we've got my colleague Luke Michaels talking about D3 and React. Beyond that, it's on you guys to get up here where Dillon stood tonight and help us with your JavaScript expertise. And with that, we'll see you guys next month.